Let's start this. So these questions, I wouldn't say difficult. Once you know what you're doing, you can get through. And you can get through it very quickly. All right. So the IL, remember, there are some equations that you have to know in order to do these questions thoroughly. So I think most people knew this one. S is equal to I conjugate IV. Everybody should have know that one. If you don't know that one, make sure you know that one. Because that is an equation that you for sure will need to use. Right? Let's have a little balance up. You have to know what this is here. Yeah, I conjugates and a V. This here is the foundation of this question. That if the first equation you had to use anyway. So you have to know that one. Alright? So second thing, I assume everybody here have a good enough calculator. I'm gonna tell you something. If you don't have a calculator that could work in Phasor, please get one that can, or borrow one from one of your friends for your exam. If you get it, make sure you know how to do complex numbers. And okay, if you don't, it can be painful in this exam with this. Because this question has a lot of phases and complex numbers. Yeah, your calculator must be able to go in complex mode, and your calculator must be able to plot phases and complex numbers and stuff. Because I don't think Sharp could do it. I'm not sure if Sharp could do it. I don't think Sharp, I don't know. I don't have a Sharp. I have a Casio, so my Casio could do it. So guys, if you have a Sharp that cannot do, or if you have some Sharp calculator or some incompatible calculator with your UV degree, yeah, get a good one. Get a good one. Talk to your maths friends or somebody, or look at someone of your friends that have a good calculator. Either borrow one or buy one if you could, because it will help you. Now, when you put this course with the courses I have to do in semester 2, you will need a good calculator. All right, so I assume everybody have a good calculator, so it doesn't stop. All right, so there you go. IL, remember this here? Yeah, you need to use this equation. So Z is equal to V by I conjugate. That is the equation you had to use for this. All right, so from this here, IL, this is basically what you want, right? And this here is a complex impedance, meaning that it has a real part and an imaginary part. So what I like to do, I like to write it in one time. So the real part of this will be the resistor and the imaginary part will be for this one. Luckily in this question, they already gave you it in the imaginary part with the J. You get through. If they didn't, you will have to either use the equation XC is equal to J, well, minus J on omega C, or XL is J omega L. You have to use this equation first to get into this before you plug it in. So just be careful. Yeah, if you note, like if they just give you like 10 farads or 3 henries and they never gave you it in impedance form, you have to use this equation here to get it in terms of this. Then you could use it. So just be careful. You have to be switcher when you're doing the questions. If you're not, you could get tricky up. And while you're doing the past papers, while you understand it, yes, but just make sure and analyze the question before you start it, because he could just change up the values and you just the thinking you do the correct thing. But anyway, so let's start. So we have this here, what they gave us in the question. Remember I told you, you're looking at this piece here, right? This piece here, if you want to reduce it, that'll be 0.1 plus J 0.02. Yeah, real simple. Let's combine the two of them together. So that did, which is good. This piece here, remember I told you, log and this 0.8 if you all didn't know, is called the power factor, right? The power factor, remember, is just P on S. Yeah, so just remember, they just cos the angle of that when you divide it. So just remember those stuff. Once you remember, guys, once you know what you're doing, you get you. Alright, so remember I told you, this is our log. Remember, log is on top, right? Remember, log is on top. And this basically just telling you what the power factor is. Alright, so if I draw anything, that's the triangle. Everything will always boil down to a triangle. So if they give you multiple of these boxes, you just have to draw the triangle for them separately and add it up together. And it will still boil down to one box. So just the one box will be like a sum of all the boxes together. Keep that in the back of your mind. So if they give you multiple, do them separately, calculate the S, the P, the Q for them separately. And when you do that, just add up everything together and you get through. You just, once you add up everything together, you just boil down to a question Similar to this, now you just go through all these steps. Let's keep that in mind. So Adrian, this triangle will be on top, right? Because it's a log. Yeah. So what I gave you, this kilowatt, this is P, right? So if you all didn't know P, the unit for P is watts, S is volt amps, and Q, which is the reactive power, is var. Alright, so right, it's at the bottom. So power is watts. So if you see them say kilowatts, that means that is done by P, right? If you see them say VA, volt amps, that is here the hypotenuse. And if you see them say vars, we're talking about here, Q. Yeah, so let's be careful how you doing the questions. Alright, just be careful. And the angle is just cos inverse of whatever they give you inside here. In this case, it's just 0.8. Yeah, so that's how the question is settled. Forget everything else. The first thing it does do when they give you these questions, obviously you can reduce this down to the impedance part. But the first thing you have to do is look at these big boxes here and draw the power triangle first. That's the first thing you have to do. Forget about answering any questions. Forget about that. First thing you need to do is to draw the power triangle. But from this power triangle, you will get everything else you need to do in the question. So even in the power factor correction, all that thing, you still need to draw the triangle. Everything always boils down to the triangle. Yeah, and to break down the triangle, this piece inside here is just cos inverse however they give you here, 0.8. And depending on what they give you here, in this case, they gave me P. So P here is 50. Yeah. If that give me like 50 VA, that'll be up here. If that say 50 VAR, that'll be here. Yeah. So let us go through. So now going on the next page, do the question, because I don't have enough space on this. So let's go and draw the power triangle over. So there you go. What is 50? Right, cos inverse of 0 point, you take a laugh sheet, put that in a calculator. So the angle for this power triangle will be 36.86. Opposing, right? Lag. Remember I told you this lagging, so it's on top, right? So the angle will stay as positive. If this said lead, the angle will be negative. Just remember that. So if it's leading, the angle will be at the bottom. The power triangle will be at the bottom. So the angle here would have been negative. So if I had a lead, same cos inverse, so it'd be cos inverse say 0.8. If I get that, this will be at the minus. So it'll be minus 36.86. So there's this, if this set is lead, this is how you will draw the power triangle. You could obviously draw it on top, obviously, but the angle will be negative. Just remember that. Just remember that. But I like to draw it at the bottom so I could see that the Q negative and the P positive still and the S doing something else. Yeah, but just remember that lead at the bottom and the angle will be negative. Log everything on top. Positive. The angle will be positive. So just remember that. Alright. So, there you go. So we have the power triangle here. So we could use a little bit of tricks. Remember, power factor is the ratio in between the apparent power and the real power. We know this, right? And we also know what the power factor is, so we can actually get what S is. Yeah? Just using this simple equation. So if you plug in the values, we know the power factor is 0.8. We know P is 50K. So therefore we could find what S is. Very simple. Yeah, it's nothing difficult once you know the equations. So when you do that, fling that across, divide, you'll get S to be equal to, that would be 50K 0.8. So you end up with 62.5 kVA, converse volt amps, right? So this here is 62.5 kV. Very simple. And if I wanted Q, well, you see, so we have an angle, this will be the opposite, this is the adjacent, and there's the hypotenuse. So we have A and we want O, so tan theta will equal to opposite on A. So in this case, the opposite is what we want, so the opposite here is Q. So Q that's equal to A by tan theta. Here are simple tricks. So A in this case is 50K, tan, and the angle is 36 0.86. So I put in a calculator, so 50,000 tan 36.86. And that'll be 37.486 kilovars. All right, so that's what this is here. So this is 37.486, sorry, bars. All right, so that's all power triangle. Yeah, rest simple. It's the same equations. Breaking it down. After you draw a power triangle, the first thing I do to draw the power triangle, they will give you values. They could either give you S, they could give you Q, they could give you P, as in this case they gave you P because the unit wasn't watts. If you draw a power triangle, they will always give you the power factor, cos inverse, so that is the angle. Cos inverse, however, they give you in the decimal, that'll be what going in there. And whatever they give you, the value they give you, it'll give P, S, or Q, it just put it in triangle. And from there, you could just use simple tricks to get the rest of it. Yeah, that's literally all. From this equation, you will always know what P and S is. The only one you will have to use to actually calculate for is Q. You have to use that trig ratio. But P and S, you always know where it is from the power factor equation. Yeah, so the two that you can remember is this here and this up here. You can put that into remember. That'll just use the same thing. Because obviously you're noticing that we could actually use the hypotenuse and A, the cos, but nah. Why I wouldn't use that? Because this one here come from this. It is easier to use one and this to get. Instead of using a value that you get to get, it would just be more accurate. You get the same answer, but it'll be more accurate just to use the P and the Q in this case. Yeah, but that's the first step. We go in. That part there is real simple. If that give you a next power triangle, you just do the same thing. And then after you do that, you just add it up. You just find the sum of both of them. So overall S, overall P, overall Q, you just add it up. And you just end up with a resultant power triangle, which is the sum of all the others. Yeah, see it. If they give you two, like if that two logs, like if that give you a next load and a next log, same thing, you do the same power triangle, you end up with two power triangles and you just add the S to it, add the P, add the Q, and you end up with one power triangle at the end of the day, and you can do the same steps you did before. Yeah, so that's keep that in mind. Alright, so I looked so the first thing I wanted was IL. So we still go and go I. I think I see a question. Oh, wait, I didn't start the record. I was starting the recording. I think I recorded, yeah. Recording? Yeah, recording. All right. I will send you recording in the chat and I'll send it to whoever they want to send it to. All right. So don't beat up, don't beat up. I'll send it. I think I don't know me send. I don't send. All right. So let go. So you want IL. So let's go through this quick. So IL. So I'll use red. Kind of thing like going to the next page. So S. S is equal to V by I conjugate. Yeah. And if we go back to the question, V in this case is 440 because it gave it here. Yeah, so there's V, right? We only say we don't have is I conjugate, but we could get I conjugate now, right? So we know, okay, that's transpose. So I conjugate would just equal to S on V. Yeah? So that's plug it in. So we know I conjugate would just equal to 62.5 K divided by 440 angle 0. So now you might be asking, right, where's the angle for this? Remember this here, the S. Remember S is this here, and it have an angle to it. So what I want you to remember is all these questions here it is in exponential form, meaning that it has a magnitude and it has an angle to it. So always remember that. So in this case, the angle for S would just be 36.86, right? So just remember that. When you write an S, you must write the phasor for it, for both of them. Yeah? So this case is 0 because all I give it in the question. And this case, the power factor, the angle for the real parts is 36.86. Yeah? Well, there's the part where I tell you, if you don't have a calculator, I can do this pressure. So I have a calculator, I can do it. So I'll do it with my calculator, it'll be 142 at an angle of 36.87 degrees. Yeah? So that's what I get. But this is I conjugate. We want I. Yeah? If you want IL, right? All you do is just find the conjugate of it. So the conjugate of something is just the negative angle of it. Yeah? Because remember, if you have something up here and I have an angle here, if I want the conjugate of this, it would just be this, which is a negative angle. Yeah? So in this case, I would just be 142 at an angle of minus 36.87. And that is what IL is. That is it. That's all IL is. So the steps to find IL will all be the same no matter what type of questions they give you. The longest part I will tell you all will be the power triangle part. If they give you multiple power triangles, it's the same steps to work it out. You just have to add up all together. Once you add up all together, you're going to end up with one value for S, like ST, if you want to call it that, a total S. And it's the same steps to calculate I. Yeah, that's how the final result and follow them, please. Yeah? So that's how you calculate I. Okay, so now that we do that, we can actually calculate what the load is. Alright, so that is I, right? So now I could actually go to the next page. Should I go back there? So the next question now we to do is calculate the voltage drop across VL. So VL, remember VL is this here. And voltage is is current by resistance. But in this case, I don't have resistance alone. I have impedance. So when you're doing it here now, it will just end up being V load. But that's equal to IL, which you just find, multiplied by the impedance, which is this here. Yeah, that's what it is. All right, so go back down. So we know, I probably do that on this page, because I don't want to go back to the next page. So we know, all right, B. So that would be VL. That's equal to IL multiplied by Z. So we know IL is 142 angle minus 36.87. Right? And we know that the impedance is this here, so it'll be 0.1 plus J 0.02. Yeah? And once you do that, you can get what the load is, the V load. Right? So once you do that in the calculator quickly, you should end up with, let's see, 15.87 angle minus 10.3. Yeah, good. Okay, and that's how you calculate VL. So VL is the same equation here. IL, you just have to use this equation where you have to do the power factor and the power triangle to get what S is. Once you have S, you will know what V is if you get I. Conjugate. Once you get I conjugate, you get I by just inverting the angle. And once you have I, everything has gone just flow. Yeah? So we have VL. We just calculate what VL is. Yeah, so now we can calculate C. So C, the source voltage, right? So if you go back to the diagram, remember the sum of the voltages in a loop will equal to the sum of the voltages at the source, right? So this Vs is comprised of this VL plus the load. This VL is called V line, right? If you are confused. V line. And this is here is V load. Yeah? So literally Vs will just equal to V line plus V load. So V line number, we already calculated what V line is. So it's 15.5, sorry, 87 angle minus 10.3. And the V load was still the 440. And they gave you any question. Get right here. Yeah. And once you add that two together, you'll get up with 455.62 angle minus 0.35 volts. Yeah. And I say you'll do the source voltage, Vs. Right? So we can actually do everything else right here. So D is the source power factor. Yeah. So the equation for that is a very simple equation. So the source power factor would just equal to cos of the source voltage minus the current. All right. So this theta V here, you already have it. Yeah. So that is this. And the current for the I think it was 36 point something, I believe. So once you do that, you just end up with minus, it'll be cos minus 0.357. Yeah, this here is the voltage, the angle for the voltage, the source, and the current. It has minus in both of them. And you get your answer. Yeah, that's the dualities. Remember your load, the voltage for your load was zero. Yeah, so yeah, so that'll be cos. The voltage for the load, if you go back to the question, is zero. Okay, it has no angle there. So it'll just be zero. So it'll be zero minus and theta. You already calculate. So that's be the. So you just end up with what the half there. So if you didn't catch it. Right, that is literally all it is. You might be thinking a minus is a plus. It would just be the minus and inside. Yeah? That's all it is. You're supposed to get back this, because this here is the angle. And that's the power factor also. Yeah? That's all it is. That's literally all it is. Nothing much and nothing less. Alright, so let's see where we at the phasor diagram and then the power factor. And that'll be it. That'll be it. So let's plot the phasor diagram quickly. So to do the phasor diagram comprise of the load. Oops, malapaganda. Let's carry this by. Start with currents. Quite cups up. I'm sorry about it. It's was gone by. Anyway, so I look to do this quick. So to do that, and I can memorize this. So to plot the phasor, that's you need V load, you need V line, and you need V source, which are things you would have calculated before any question. Yeah, just remember this. Once you remember these things, the question very simple, but the questions are stated the same. So to get the phasor, you need these three things all the time. All right, so V load, you already know what that is. It's 440 angle 0. Yeah, V line, we already calculated already. 15.87 angle minus 10.3. V source, that was the last thing we calculated. That was 455.62 angle minus 0.35. Yeah, you have already calculated. This one does give you any question. This one here is the first thing it has calculated with the V line is equal to I line by the impedance, ZL. And the first thing it does not make calculate. After you calculate I does not make ask you to calculate it anyway. So you will have this. V source does not make ask you to calculate that. Yeah, V source will just be the V line plus the V load, which you already have. There's the part which is this one, so you can already get what VS is. So you will have all these things already. So you just wait to draw the phase of it. Alright, so I look to draw it. So the first piece, you just draw this piece. Because we're using this equation here to get how this will look, right? We know that VS is basically V line plus V load, right? So just remember that. So you have to add V line and V load. So I do that. So V line is this. The angle is 0. So it ends in here, right? So use a different color. So now that is V line. We have to add V load to it, but V load have an angle to it, right? The angle is minus 10.3 from it. So we can just draw this, and minus 10.3 would be like right there. So this piece here will be what V line is. So that'll be like, so that'll be 15.87 angle minus 10.3. Yeah? And then we know that this is V load and this is V line here. So both of these, some of these two will give you what your sources. So at that point, you don't really need to do anything else. You just need to connect the two endpoints. And you see how good I could draw that? Ooh, no, that's cool. That's cool. There are no straight lines on this because it's not a notepad. Let me see if I can ratchet. Yeah, man, we inside. So this here is Vsauce, and this here is 455.62, and the angle is minus 0.35. And that is it. That is how you plot the phasor fit. Let's remember this equation when you put in the phasor. The Vs, as you see here, is basically V load plus V line. And once you remember this equation here, you can get well how to plot it, and you will know what you need in order to plot it. Just remember to plot the phasor, you need these three things. It will not change. It will not change. You need these things to plot the phasor. You must. V load, V line, and V source, you need it. You really need it. And you would have calculated it before any question because they will have asked you to calculate it in the first place. And to do it, you just look at this equation here. From here, V line, well, V line plus V load will be 0. Yeah? So that'll be the first thing I plot in green. And then from the end of that is where you had to draw the line. That's using normal angle, minus 10. I drew the dotted line across. And then measure it across and then draw the line. And once you put the V load on V line, you can just connect the two endpoints to get the V source. That's the result of. Yeah?